Alright, so now that we know how to measure and read drawings, it's time to learn about the tools that we use to take that knowledge and transfer it to the material that we're working with. Today we're talking about Chapter 6, Layout. So what is layout? Layout is a metalworking term to describe the marking of lines, circles, arcs, and points for drilling holes in metal. This is where we take all the information from the plans and then transfer it onto our material. We're working with metal, so it requires some special tools. First thing, we want to be able to mark on the metal itself. Your first thought might be a Sharpie. Your first thought might have been a pen or a pencil. And pens, pencils, and Sharpies aren't going to cut it. Pens and pencils do not last on there. The graphite of the ink just doesn't stick to the oily metal. And like we talked about in the measurement lesson, metalworking is all about precision. And even with a brand new Sharpie, the tip of this thing is way too fat. There's too much variability. It's not accurate enough. So we use a variety of different tools to work on our metal. The first thing is we want to be able to see any scratches on there. And we do that with something called layout dye. Now layout dye comes in a variety of different colors. The bottle that we have right now is red. We've also had blue. Those are usually the two colors that you'll see in industry. The layout dye also goes by the name of Dykem. This is a bottle of layout fluid, layout dye, made by Dykem. It's the same way how adhesive bandages are called Band-Aids. Band-Aids is a company, but they've just gotten so good at it that a lot of people refer to it as Dykem. Now, that's a dye. You lay it down on whatever material you're working with. It dries rather quickly. And then we can begin to scribe our lines onto here. To do that, we use a tool called a scriber. This looks very similar. It's basically the same handle as you would get at a Phillips or a flathead screwdriver, but the end is ground down to a very small tip. That tip is, this one's wearing in, no, that's all right. This tip is very point, so you can have a very precise line. So I have here a steel rule that we've learned about in measurement, and if I wanted to draw a line directly across this piece, I lay my steel rule down, I put my scriber up to the side of it. It may be hard to see on camera, but the scriber removes some of the layout dye and leaves a nice, crisp, accurate line. And we can cut up to that line, we can bend on that line, we can do everything from there. To lay out accurate lines with this, you want to make sure that whatever you're drawing up against is placed accurately, and also you want the tip to be sharp. The ones that we have here in the shop are pretty good, but if they get worn down over time, we just grind them back to a sharp tip, which is why you want to be careful with this. It is pointy. So the scriber is great for straight lines when we follow along with the rule or anything like that, but if we need to draw any arcs or circles, then we need to use a different tool. We don't want to freehand any of those. We have the tools to be accurate. If you've taken design tech, you may recognize a tool similar to this. This is not a compass. These are dividers. This is a pair of dividers. And it works very similarly to a compass. So the way that this works, you have two pointy ends now, and they're connected here. You can loosen, open to make them wider, bring them closer, and then tighten this thumb screw to set it to a certain distance. Point here is that one tip is going to be set at a certain spot, and then the other one can be moved around to create an arc. These measure in radius, so if I want to cut out a 4-inch diameter circle, I have to set this to 2 inches. Now, how would I set it? Take it up to my steel rule. One tip at 0, one tip at 2. Tighten that down. Now I can lock that in at the edge. It's moving on me a little bit. But that's how you make an arc, with a pair of dividers. Now here's another tool that looks similar to dividers. It works in a similar way. It opens up. There's a screw down at the end where you can loosen it to adjust it or tighten it to make sure it's locked in. These are called hermaphrodite calipers. One leg is pointy, just like a scribe, and the other side it's a little bit hooked, it's a little bit duller, and we use this for reference while drawing a line offset from the edge of a piece. If I want to draw another line just like this, and I want it to be 1 inch in from this outside edge, what I can do, set up 1 inch, make a mark, go a little bit higher, go in 1 inch, make a mark, and then use my steel rule and my scribe to connect the dots and make a line on 1 inch. This does it faster for us. These hermaphrodite calipers, all you have to do is set it to 1 inch. I'll draw it in on this side. Set it to 1 inch. The hook goes on the 0. The mark goes on the 1. Make sure that's tight. Kind of hold that in the back of your palm. Fingers on there. The hook goes on the outside of that sheet metal. With a little bit of pressure goes on the other leg. And then we can easily make repeatable scribe marks all at 1 inch. Let's see how I did on this one. Not bad. So all of these lines, these practice lines that we've scribed so far, have just been parallel from the outside edge. But a lot of the times you need lines to be specific angles. And the most common angle that you'll find is going to be 90 degrees. It's just going to be a square corner. So we use a few tools for that. We've talked about these before. We have steel square and then a combination square. I can line this up with the edge of my material. And then I know that this inside edge will be 90 degrees from this outside edge. I can do the same thing on here with my combination square. I'm already get into the picture. I'm not sure if you're able to see that too well, but I hold it up against here and I know that this is perpendicular. Over on the other side is a 45-degree angle, which is another common angle that we're going to use. 90s and 45s aren't the only angles that you're going to make. Sometimes you need to be more precise and make an angle, let's say a 60-degree angle. To do that, we have a protractor. This protractor might be a bit nicer than those plastic ones you use in middle school math. What we can do here is loosen and adjust this thumb screw, set it to 60 degrees, tighten that down, and then I know this inside angle is 60 degrees. This straight line is 180 degrees, so since this is 60, I also know that this angle is 120. So this is a very useful tool to make precise angles. Now, Mr. Jones, these are all great if we're using just pieces of steel with straight edges that are perpendicular and square and everything. What happens if we're using something round? What happens if you need to find the middle of a piece of round stock? Well, here's a piece of round stock. This is just going to be a demonstration, so I grabbed a little puck of titanium to use. To find the middle of that could be difficult, but we have a tool to do it. This right here is our center finding gauge. This isn't just an angle, corner. It's a 90-degree angle. And this arm that comes off of it is directly in line with the middle of it. So what I can do is set this down on top of my round stock. I'll flip this over so you can see there's these edges. You make sure that it's touching both sides. And what I would do is scribe a little bit through the middle. Then rotate this to do another one. And then it's just good practice to do a third one. And where all those lines meet, X marks the spot. That's the middle of your round stock. So 3 of the last tools that we just used were the combination square, the protractor, and then the center finding tool called a center head. These are all very good, all very important individually, but we have a tool that combines all 3. And that is a combination set. Here in a combination set, we have our steel rule as the base, similar to what we would have in a combination square. Then, on the inside here, the camera might be able to pick it up, we have a protractor. So what I can do is loosen this thumb screw, move that back and forth if I need to, loosen this thumb screw, and then adjust this to whatever angle I may need. So then I can put this up against stock, and I know that that is at whatever angle I need to add in my layout. Also on the back here, we have a level, so we can tell if something's perfectly level or perfectly plumb. Then also on the other side is a dividing head. So here we can find the center of some round stock as well. Also, we know that if this is 90, that's a 45-degree angle, so we can use something for that. This is very useful. Now to continue on working with round stock, we've already talked about finding the middle of the end here. But what if we want to do some layout on the side there? Grab a bigger piece, just so we can use this as a demonstration. If I need to do some layout work on the side here, if I want to, this is actually a good example, if I wanted to drill another hole just like this, 1 inch below. Well, if I were to try to line this all up, it's exaggerated, but it's going to roll away from me. It's hard to figure out if you're perfectly perpendicular or anything. You want to be able to hold this still. So we have our V blocks. This is a big chunk of steel, pretty heavy, and cut into it is a V. This one actually has 3 V's. Now I can put my stock directly in there and then work over the top to make sure that this does not move on me. So the last part of this definition for layout, which again describes the locating and marking of lines, circles, arcs, and points for drilling holes in metal, is marking points for drilling holes. To drill a hole, you need the size and you need the location. We talked about this in the drawings, right? Reading and understanding drawings. If I have 2 lines that intersect, that's going to be my center point, right here. Now, drill bits work because they are very hard. When you're drilling into wood, you have a solid steel drill bit. When you're drilling into wood, it's pretty easy. It works pretty well. Metal's pretty hard too. So if I were to just drill on this as is, the tip of my drill bit might, I'll exaggerate, but it's going to skate around because it doesn't know exactly where it's going. What I need to do is give it a specific spot to go. And that's why we use center punches. I have right here some center punches. Then there's a little bit of, oh, not that. There are two different types. There's the prick punch and then the center punch. Prick punch is a bit sharper. It's a 60-degree angle compared to a 90-degree angle of a center punch. But here's what this does. I want to drill a hole right on that intersection. So I have a hammer. I have my center punch. I put it directly on where I want it to go. And I just give it one, maybe two taps. One would have gotten away with that. Yeah, I could have gotten away with one there. But now, it leaves a little indent right there. So now when I go to drill, the tip of my drill bit sits in that indent. It doesn't skate around on me, and the flutes can do their job and cut the material. A center punch is also useful for when you're using the dividers. Earlier on, I didn't want to get ahead of myself by introducing that too early, but these really work if you have a center where it's turning around from. So one divider there, and now that is a perfect arc. Layout is incredibly important. I know that using all the tools and making sparks and cutting stuff up is really where the attraction of metalworking is. But if you don't understand how to properly measure, properly read your plans, and properly do the layout for whatever you're making, your final product will not be at the level that it could have been if you take the time to do it right at the beginning. All of these tools are right here in this cabinet behind me. You're going to see in a little montage in a minute where they all go. If you're looking for something and it's not there, it's because someone else didn't put it away. So please don't be the one who doesn't put something away. Right? Let's take care of these tools. They do a lot for us. We can put them away and make it easy for other people to find them. If you have any questions, let me know. I'm happy to help.